Hey everybody, so today we are more or less doing an extension off of yesterday, but it's just 3 example word problems, and then I'll give you some word problems for your assignment. The key to all this is you got to draw a picture. If you can't draw a correct picture, that is, this is not going to work for you. So I will walk you through kind of how to do that. And again, you got to be at gg.gg/LoganCalc for your calculator. Okay, first one says you're building a bike ramp for you and your friends to use. Using a 6-foot board, you build a ramp to be 3 feet high at its highest point. At what angle are you taking off? Okay, so first of all, you get to laugh at my pathetic drawings here. So here's your bike. That's a bike, right? And there you're on it. This is actually not that bad. There you are. That's not terrible. Okay, so there's your bike. You're on your bike. You're smiling. You're laughing. You're having a good time. Okay, and a ramp, what does it look like? Like this. Let's use some information that they give us now. They say the ramp is made using a, oh boy, wrong color, 6-foot board. So think about how you'd build the ramp. I would put the board right here on that red portion. So that means this is going to be 6 feet. It also says you build the ramp to be 3 feet high at its highest point. So right here is the highest point, and it's 3 feet off the ground. So this is 3 feet. I kind of got a little ahead of myself, but since it's like a ramp, it's going to be at a right angle down here. Now the question asks, at what angle are you taking off? Okay, so what we need to do here is figure out, okay, how am I taking off? This is our angle. So let's list out, this is just a little bit different, but it's still pretty easy. Let's list out what we know in terms of my angle. This is my theta. Well, my opposite value is 3. Do I know my adjacent or my hypotenuse? Well, here's the right angle. 6 is across, so I know the hypotenuse. I don't know what A is. I don't care, because I only need 2 letters to figure out if I need to use so, ka, or toa. Okay, you should know that, oh boy, you should know that, I can't work my iPad, that O and H is so. So I'm going to say the sine of theta of my angle is 3/6. Well, 3/6, that reduces. You don't necessarily have to do this. You could use the calculator, but just so we're all aware, it reduces to sine of theta is 1/2. Now you could use your unit circle and figure out, hey, where's the y value equal to 1/2? Or you could just use the calculator, like I said, and go to your calculator, type in, oh, I guess we got to get theta by itself. So in order to get rid of this sine, we got to get theta by itself here. We're going to take the inverse sine of both sides. We should be familiar with this by now. We get theta equals the inverse sine of 3/6 or 1/2. If you put 3/6 in the calculator, you get the same answer. Inverse sine of 3 divided by 6, you should get theta equals 30 degrees. Okay, moving on to the next one. Next one says an airplane is at an elevation of 25,000 feet when it begins to approach the airport. So here's my airplane. Oh boy, this is going to be embarrassing. There's the tail. Kind of looks like a shark. There's my airplane. Okay. If the angle of descent is 8 degrees, what is the distance between the airport and the point on the ground directly below the airplane when it begins its descent? Okay, so what we got to do is, here's my airplane, my airport, so let's put it down here somewhere. There's my airport. And we got to make a triangle out of this. So there's a height, there's a length, and there's a distance right there. Okay. It says airplane is at an elevation. The key word for or not really keyword, just you got to understand what elevation is. Elevation is how high you are in the air. So that would be a vertical distance. Which one of these sides is a vertical distance? I would say this one. So my elevation is 25,000 feet. The angle of descent, well, how is my airplane, where is it coming down from essentially? Is it coming down from this angle, or this angle? Hopefully, you said this angle. So that angle is going to be 8 degrees. It says, what is the distance between the airport, so between this piece and the point on the ground directly below the airplane when it begins its descent? So between here and here. Well, I didn't draw my triangle like that. I don't even have a triangle drawn right there. Well, think about it. This is going to be the same as this point, and this point is the same as this point. So I could have just drawn my triangle like this if I really wanted to. I could have drawn it. I'll do it in green, I guess. My triangle could have looked like this, and I would have had the exact same scenario. It's just my triangle's flipped. So I'm going to be finding x up here. Okay, again, so in terms of my angle, in terms of 8 degrees, I got to list out O, A, H. Opposite of my angle is 25,000. My right angle is here. Do I know what the hypotenuse is? I sure don't, so I don't care. I know that the adjacent side is x. OA, SOHCAHTOA, I should use TOA here, so I should use tangent. The tangent of 8 equals 25,000 over x, put it over 1. Boom. 25,000 equals x times the tangent of 8. How do you get x by itself? Got to divide both sides by the tangent of 8, divide by the tangent of 8. Those cancel. You get x equals 2,500 divided by the tangent of 8. Just go to your calculator, type that sucker in. 2,500 divided by the tangent of 8. You should get a big number. You should get x equals 177,884.24. 177,884.24, and we are in feet. That is your final answer. Okay. Next up, last one. A student looks out of Mr. Adler's second-story window. Spoiler alert, my classroom doesn't even have a window. Anyways, someone is in my window up here, and they're looking out. Okay. And sees a low-flying bird. The angle of elevation to the helicopter is 53 degrees. What the heck? I have a typo here. And sees a helicopter. Let's say that. Whoopsies. I must have tried to combine two problems. So a student looks out my window and sees a helicopter, not a bird. The angle of elevation to the helicopter is 53. So I got to fix my drawing here then. Sorry about that, people. So you're right here, and they see a helicopter. Oh boy, how the heck do I draw a helicopter? Okay, we got that. We got a little thing for people to stand on. It goes back like this. Got a little tail. No, I can't even see that. There, helicopter, sweet. Okay. So angle of elevation to a helicopter is 53. So I'm looking up. This is how I'm going to finish off my triangle. Now, you can do the blue or you can do the red. You're going to get the same answer either way. The values are all going to be the same. I'm going to do the blue. So it says the angle of elevation is 53 degrees. The student is 20 feet above the ground. So this student right here is 20 feet above the ground and 200 feet from being directly below the bird. Helicopter, bird, holy cow. The helicopter. So this is this value right here is 200. It's asking for how high is the bird off the ground. So we got to find what this value is. Now, in the very end, what we're going to have to do is, since I'm right here, and then from there to the ground is 20. Once we find out what x is, we just got to add 20 onto it to figure out how far off the ground it is, because x only tells us this length, and then 20 is that length. Talk about a typo and a problem. Holy cow. Anyways, so again, in terms of this angle, I got to list out O, A, H. What is opposite of my given angle of 53? It is x. Here's my right angle. My hypotenuse, I don't know. I don't care. My adjacent side then is the leftover one, which is 200. OA, you should know by now. OA, we're going to use TOA, so tangent of 53 equals x over 200 over 1, cross multiply. X equals 200 times the tangent of 53. Go to your calculator. 200 times tangent of 53. You should get 265.4 feet. And again, that only told me this length. There's 265. I got to add in this yellow, which is 20. So just add 20 to it. And you should get 285.4 feet as your final answer. Okay, my apologies for that last problem. I got to go in and change that. That is beyond ugly right now. But it all made sense in the end. If you have any questions, feel free to send me an email.